So part two, the last part of our class series. It's been a real pleasure to have you all in class and to provide this information to you all that I hope you found valuable. So, wouldn't you know it, to end with the idea or the impact of the internet. I mean, how amazing it is just to look at daily life and how the internet has impacted daily life. However, getting back to the subject at hand, getting back to the course material, the web has changed the way we think about programming. We're now able to offer software as a service. Just look at Microsoft, look at where they're taking the Office product. It used to be that you bought a disk, that you installed it on your computer, that you used it locally, and now we're able to use it online, share documents dynamically, work in real time with people all over the world to, create documentation, spreadsheets, presentations, you name it, to make companies productive and profitable. And of course, we still see a lot of the integration of that Office suite or similar suites of software integrated into other software programs that we use to run our business. So HTML documents, well, that's pretty easy. That's a web form. That's anything that we would do on the web. Granted, we're now at HTML version 5, so we're doing a lot more within a client's browser than we've ever been able to do. So shifting the responsibility for the interface from the client to the server simplifies data transfer, and the results in lower hardware cost and complexity, because although we're building more advanced software, they're being held on a much more simpler infrastructure. So, you all have heard this term, cloud computing, refers to the cloud symbol, right? Refers to the big I internet. What the heck does that mean? And, just like now, I just recently finished a volunteer project where I built a website for a nonprofit using WordPress, and just inside that WordPress is the ability to correctly display that website, whether I'm on a smartphone, thus stacking the website, on a large screen, on a tablet, etc., on Android, on iPhone, you name it. So cloud computing, of course, requires significantly more bandwidth because we are utilizing the web. Just look at Netflix for example. Look at the people who are getting away from cable TV and subscribing to 2, 3, sometimes 4 cloud entertainment services, whether it be Netflix or Hulu or other services like that, to get their entertainment. The same thing holds. And what do we need? Well, in the case of Netflix, we need a pretty simple application, a pretty simple back end that is going to reach out to servers. It's going to grab whatever show we want to watch. It's going to stream it based on our bandwidth. So it knows how much bandwidth, it knows how much it needs to cache before presenting. But in all actuality, pretty simple and basic application. So with cloud, and remoting in, we can remote in through the internet. I do that all the time. Remote into servers that I have on campus for my server classes. Do demonstrations live while on the internet for, say, when I can't be in class. So Web 2.0, like I talked about, we could be on many versions. Who knows what you would call it, but applications will deliver software as a continuous service with no limitations on the number of users that can connect or how. We're there, frankly. Goal is to enhance creativity, interaction, and shared ideas. Who would have ever thought that Adobe Photoshop would be available as a web-based software as a service? And indeed it is. So in-house solutions, a unique website with a look and feel consistent with the company's other marketing efforts. Of course, we wouldn't necessarily hold our production website inside our network because of the security, but these may be web pages that organize pages of data and specific files and projects and all of the project calendars together and everything we need to be successful. That would be SharePoint, by the way, as one application that does that. It's hugely scalable. We add more disk space, we add more resources, and we can just continue to grow the use of e-commerce or other applications in-house, if that makes sense. So, and of course, e-commerce. I mean, who would have ever thought that, PayPal, we don't just have money anymore. We don't just have the ability to charge. We have unique currencies, currently Bitcoins. What the heck is a Bitcoin? Look it up. It may be what you use to do purchasing, selling, and trading items in the future. Firm's web-based business systems within its other information systems, creating the potential for more savings and better customer service. We're able to utilize all of this data better. That's the key. We're able to give more data out to customers. We're able to put customers closer to information that they may need to purchase our products, to become a customer, to allow us to offer services, to gain services that they need in real time. So package solutions, well, many vendors include Microsoft and Intershop offer turnkey systems. Those can be e-business systems. We see this in websites now, turnkey websites, turnkey social marketing systems where, hey, let us work your website, let us work your Facebook, let us work your Twitter, let us create and generate, marketing prospects for your business. Service providers, so, ASPs, application service providers, full-scale internet business services for companies that decide to outsource those functions. We're talking about, in some cases, complete outsourcing of the back end of a business. This can be payroll, this can be finance, this can be purchasing, this can be just everything, allowing you to focus on whatever it is that you do best inside your business. So literally, a multi-million-dollar business can be started from home and continued to be operated from home, as you outsource manufacturing, as you outsource warehousing, as you outsource shipping. You just had the idea, you had the product, you had the service, and you've utilized all these outsourced vendors to produce the marketing, to produce the back-end operations, and simply run a business, from your house. The old garage-based business, as they say, has now been transferred into the laptop that you take with you. So processing methods, we've talked about this, online processing systems. An ATM has to go out, your bank's ATM, or say an ATM outside of your bank, has to do a data connection to your bank. The bank has to give enough information to that ATM for a certain period of time to make sure that there's money available for you to withdraw from your bank. And then, transfer that back, take care of the accounting that withdraws the money from one bank to another, all online, all secure. As you may or may not know, each time you connect to a financial institution site that is using SSL certificates, you have an encrypted connection just for that session, which means if I log out, log back in, new encryption key, new encrypted session. So batch processing, as we said, still with us after all these years. We still see a bunch of batch processing done, things that we don't necessarily need to process throughout the day. So the idea may be, transactions. Now, what I mean by transactions is we may process a transaction through the point of making sure the funds are available, making sure the products are available, getting that transaction working, and then in the evening process the rest of the information around the transaction that works inside the business, so that we're not using valuable resources during the day or when we're operating. We can have our computers working 24/7, 365 to do the processing on the back end when it's convenient, for example. So, point of sale terminals, the idea there, think about McDonald's and think about everything that's affected by a single transaction when you buy a quarter pounder with cheese meal. Inventory is affected, sales are affected, the employee may be somehow affected, you name it, as it goes through the process. So if you think about it, at the end of day, we may have held all that information locally, and then at the end of day done a process, a batch process, for example, to go ahead and close out the books for the day, figure out enter information into sales transaction files, maybe update inventory, do accounting, do deposits, all of that stuff that can be done after business hours. So here we kind of take a little flip. We get into the idea of the OSI model. Not going to really cover this. You're not going to see much of this on the test. You get a lot of this in the 179 class. So, this is the 7-layer OSI model for connectivity, network connectivity, all the way up through the program, the physical layer, the logical layer, etc. So network topology, of course, is the physical topology that describes the actual network cabling. So this is the idea of the internet, as people think of it, the big I internet being the cloud, but it actually isn't. The World Wide Web is the cloud. The big I internet is the equipment, the physical layer that the World Wide Web works on. So this is going to be the routers, the switches, your NIC connection into the World Wide Web, into the internet to gain access to data. So hierarchical network, department servers control lower levels of processing and network devices. A bus network, which was a single communication path. Don't really need to get into that. We don't really use it anymore because the idea behind a bus was, well, if I cut that path at a certain point, everything downstream of that stops working. And in all actuality, the entire path may stop working, especially like in a token ring. Cut the ring, no connectivity throughout the entire ring because data was transmitted in one direction and one direction only. Today, though, so that's that ring network. Today, most everything is a mesh. There's that redundancy. Each node connects to every other node. This is what makes the internet work. We can take a plethora of paths across the internet to get information where we want it to go. And the cool thing with that is if one router fails or one server fails, a mesh network of servers sitting in multiple data centers all over the world, if that information is redundant, if one data center completely went down, earthquake in California, oh no, what do we do? We're not going to lose all the data because our data is redundant and there's multiple paths where we can access and find that data. So here's an idea. We don't really see as much departmental servers as we see corporate-wide servers. So things like file servers are corporate-wide. Now, if we have enough data, one file server may be dedicated to a specific department. That file server then talks to other network servers or other business servers to share and keep data redundant. That doesn't mean that we wouldn't segregate the network to create areas of security. So for example, if this was a financial department server, it might sit in finance and only be accessed by people in the finance department that have access. So from a security standpoint, we definitely see that, but we can do a lot of that now back on the network operating system. So here's a graphic of a bus. So you can see, if this was a PC communicating with information from the department server and I cut that bus line right there, everything would be affected. Token ring, same thing. If you notice, it goes in one direction, which means, if I cut it here, there's nothing getting back to the server and communication would stop. So as we can see, not a great way to do it. Standard star and mesh networks. Mesh is what creates the redundancy. So you can see that we have information that can travel through different channels versus here with a switch. We would never build a network like this today. We might have multiple servers, but we wouldn't connect them to one switch because that becomes a point of failure. So what we might do is have each of these devices, at least the devices that are mission critical, connected to multiple channels within our switch and then connected to multiple department servers so that we have that true redundancy across our network. So pretty standard model here. We'd add some redundancy. We have some sort of proxy server firewall that would secure this information and only release to the internet or only accept from the internet specific ports, specific rules for data that we allowed to transfer in and out of our network. So network devices, networks such as LANs and WANs, can be interconnected using devices called routers. So that's what we were talking about here. Again, not going to go through this in much detail because you got a lot of this in 179. There's not going to be a lot of this on the exam. You should have these outcomes. So router is a device that connects network segments. So we just give the router rules that say this is how you communicate with this segment. This is what you'll accept or deny from that segment, etc. Modeling tools. Well, we've talked about a lot of great modeling tools in here. Microsoft Visio is certainly another tool that we can use. I've used it for things as simple as drawing a graphical representation of what the network looks like, with information on IP addresses, server names, etc. Certainly can use it for things like use cases, ERD diagrams, business process diagrams, context diagrams, DFD diagrams, decision flow charts, you name it. Visio has those tools. So I'll tell you, this gets completely, in my opinion, out of the realm of what we were talking about. What you need to know about wireless is simply this. As you work on your projects or as you think about putting together services today, the question becomes, is wireless something that you're willing to put into your network? Understanding the inherent risks that still exist in wireless. Is the speed there? Is that a security mechanism you're willing to give up by not having a wired connection? Latest standard is 802.11ac. You can look up the speeds. An AD coming are currently being tested. AC is not being tested. It's already out. So really don't understand this, except that it gives you a great look at where we've come with technology. We have made huge advances in wireless. 802.11b. Now, as you look at these speeds, these are actually the full duplex speeds, so the theoretical throughput going to and from, okay? Whereas it wasn't until we hit 802.11n that these became real speeds, unidirectional. So our actual speed of 802.11b was 5.5 megabits per second. It could send or receive at 5.5 megabits per second. Once we got up to n, we ended up with dual radios in our wireless equipment, so that we had a radio dedicated for sending, a radio dedicated for receiving. And as you can see now, they're estimating 802.11c has a speed rate of 6 megabits per second. Now remember, this is not your internet connection speed, folks. This is just the speed between your wireless router and a device on your network that's working wirelessly. But who would have ever thought? I certainly wouldn't have thought back in the day. I now look at my wireless router, and just this afternoon I looked at it, 11 devices connected to my wireless router. My DVR is connected, a gaming console is connected, phones are connected, laptops are connected, you name it, it's connected. Matter of fact, my car can even connect to my wireless. Who would have ever thought? I have an automated irrigation system. It is in itself its own access point. It connects to my internet service and throws data out on the web so that from anywhere I can turn on and off or adjust my sprinklers. Who would have ever thought? So what makes it all possible? Yep, wires get, have kept us down. We're now wireless. We're exceeding those lengths and getting where we need to be. So as we talk about completing system design, final activities, preparing a system design specification, obtaining user approval, delivering a presentation to management, we're ready to go. We know what the design specification is. It's part of the software development lifecycle. We've reached that end. We've talked to users. We've got their needs. We understand our architectural opportunities here. We understand what the business needs. At the end of the day, folks, like I said, this all comes down to the simple fact of building a system that's going to work for the company, that's going to produce efficiency, it's going to reduce cost, it's going to increase revenue, it's going to do something for the business. And folks, if it starts to go awry, remember to have the courage to ask that question, is today the day this project should end? Do we have the resources in-house? Are we spending money wisely, etc.? So you can read here about what a management summary, a system components, system environment, these are all things, implementation requirements, time and cost estimates, any additional materials we might need. So again, pause and read these. All part, total costs to date for the project. These are all things that we need to keep track of. Now, as much as we need management approval, we've talked about the fact we need user approval. Users need to be willing to support the system we're putting in place. We need to have gone to them and said, if we build it, will you come? Will you use the system? Will you support it? Is it going to make your job easier? Is it going to do what the old system did? Or will it do what you feel a unique system needs to do? We get feedback throughout the process. We give presentations throughout the process. We deliver reports. We let everyone know where we're at, how the system is going, etc. So there you are, folks. That's the end of your adventure in CIS 244 systems analysis. Again, I hope you found this useful. Remember, a lot of the tools that we talked about don't have to be used just to integrate systems. We can improve physical business processes with these systems as well. We can figure out how much something is costing so that we can compare how we do it today to how we might do it in a logical IT system, how a website may be better for us, how an internal network versus an intranet versus internet services, total cost of ownership as to what it means to rent server space and build an application in the web versus building it in-house. So I hope you enjoyed the class. Take care, and we'll see you soon.